Alright, now we're going to take a look at where we'd actually use this quadratic formula to solve something that we might actually care about in real life. So, first one we're going to do is a projectile problem. We are given that we know the initial velocity, we know the initial height, and we'll be given this entire function for height. Because it is math class, we just start with the equation. It does come from a physics formula. Basically half of gravity, at squared there, and so on. That's more a physics approach, but because we're in math class, we will just start with the function. So basically, we know the a, b, and c values. Keep in mind that t is serving as the x variable here. And if we look at it, let's say we are launching something with a cannon or kicked it or whatever, and we're 32 meters above the ground, it's landing down below us at some time. We're trying to figure out at what time does it strike that ground. Essentially what we're doing is we sort of have a graph of y versus x, or in this case h versus t, which tells us that time is an independent variable and height depends on the time. So we will plug all those values into our quadratic formula, and then we'll go to our calculator and we will type it in carefully using brackets where we need to. And first thing we do there is find the discriminant value. So now we can type that in. That's what we're going to end up square rooting. And we can do this all in one line if we are careful. And go back and add some brackets here. Divide it all by negative 9.8. Notice we used the answer key there to paste in the 1027. And we get our first answer of negative 1.2 seconds. And we should think that's a little funny that it's a negative time, so we're going to have to do the other part now where we subtract the discriminant. In this case, we get it positive. We get 5.3 seconds, which seems to make more sense. Let's take a look at what those two answers mean. So first of all, that negative one, it sort of refers to a time before we actually started measuring, which actually makes sense because we were above 0 when we first launched our object. So really the only answer to this question is 5.3 seconds. Now, is there an easier way to do this? Here is. There are tons of programs you can actually get that will solve quadratic equations for you. We have one on the calculator here where we literally just type in the a, b, and c values and it will spit out the answers. Now that's pretty nice, and is that magic? Of course, it's not actually magic. There are lines of code that you can edit in the program menu that will basically determine the roots of the quadratic equation. Now, there's all kinds of tutorials online that will show you how to do this. You can download a program. We should be aware that we have to do this by hand also, but we just have another tool now that can help us out in certain situations. So just to summarize, basically what we found was when h is 0, the time is 5.3 seconds. And the next thing we're going to do now is a revenue problem that we're fairly familiar with. So basically, we've got a $10 ticket price and we think we can sell 400 at that price. Now, we figured out from some models, maybe some surveys, that if we raise the price by $3, we're going to lose 25 sales for each price increase. So we can set up our function of price times sales like we have in the past, and make sure we know that x is actually the number of times we increase the price by $3. It's not the price itself. But for example, if we had an x equals 2, that'd be an increase of $6. We'd go up to $16 tickets. So our goal is to make it look like that, with the 0 on one side. So first of all, we have to expand it out, collect like terms, and get it in terms of our a, b, c that we're used to. And we'll see that, first of all, we need to figure out, well, what problem are we trying to actually solve here? So essentially what we're trying to figure out is at what ticket price would nobody come to the concert? Maybe it's not the most interesting problem, but because it's quadratic formula section, we'll try it out. Essentially, we're trying to figure out what's the x-intercept of our revenue function. So we want to know what price would we charge where nobody would come anymore. So what would be too much for even the richest people to come to this concert? Or another way to ask that question is when would we have 0 revenue? So if we take our a, b, and c values, we can go to our calculator and let's do the shortcut way. We'll find the program and we'll plug in a is negative 75, b is 950, c is 4,000. We get a negative and a positive answer again, which makes sense because there actually is only one positive x-intercept when x equals 16. So what that means is if we increase the price 16 times $3, we'd end up with a ticket price of $58. And that would just be too much, and nobody wants to come to our concert at a $58 price. At that point, we have zero revenue. And keep in mind, we should be able to do this by hand as well and type it into the calculator without the program. And we'll kind of pick and choose when we need to do that. So thanks for watching.